period on a warm 7th period at 2:15 in the afternoon. I so appreciate you guys. You really pay attention. I'm so thankful. On a warm day. And today we're going to develop our last kind of part of quadratic equations and how to solve them. We've learned 2 ways already, and we're going to learn the 3rd way today. And I just wanted to take a moment. I found something really cool online that gave 101 ways to use the quadratic equation in real life. I know it's hard to believe that math really does work in real life, but it does. And I'm not going to develop the equations, we're not going to solve anything, but I thought it was interesting, and I wanted to show you some different ones, 3 or 4. I'm going to go down to this car here, and you will see an equation. Again, I'm not going to tell you what the equation, I'm not going to fill anything in, but I just thought it was interesting that we can take the quadratic equation and find acceleration and figure out how soon your car will stop before you crash. Notice the picture of the car, and I'll read the paragraph right next to it. The reason that this result is so important for all of us is that it predicts that doubling your speed quadruples rather than doubles your stopping distance, those of you who are driving. In this quadratic expression, we see stark evidence as to why we should slow down in urban areas, as a small reduction in speed leads to a much larger reduction in stopping distance. And I think we all know that, right? The slower you're going, the quicker you're going to be able to stop, right? And you could save someone's life. So actually, in real life, the quadratic equation is used to predict those kind of things. I'm going to go down to the airplane, and you'll see the Bernoulli. I think that's an Italian family. They had many mathematicians in them, and they liked to work with airplanes. I'll go down to the paragraph right here. There are a number of simple experiments which will demonstrate Bernoulli effect. One of the simplest is to suspend 2 ping pong balls on cotton thread a couple of centimeters apart, then blow gently between them and watch what happens. And they have a picture there of that. But they can also use the quadratic. You'll notice the quadratic up there. If it's got a squared, it's quadratic, right? See the squared? And the Bernoullis like to use it with aircraft. Look up above there. It says, however, this quadratic equation is accurate enough to predict the behavior of the flow of air over the wing of an aircraft and see why an aircraft flies. Again, another way that quadratic equations are used. Another one I wanted to show you is this one, and that is insects. Imagine you're a biologist or ecologist who is interested in the way the population of a particular species of insect changes from year to year. And again, I'm not going to go into the formula, but if you'll look down here, you'll see it. And again, they're using quadratic. You see the squared right there. So just to finish this out, I know some of you are really excited about this because you like science. This was kind of funny, I thought. Look at the conclusion. We've shown that the quadratic equation has many applications and has played a fundamental role in human history. Here are a few more applications. Look down there. Refrigerators, sunflowers, planets, badminton, radio, pendulum, weather, falling, showers, golf. All of those real life things use the quadratic equation. I just think that's pretty cool. So I just thought I'd show you guys that before we take off on the quadratic formula today, which Sam has anxiously been waiting for. And so take out your notes, and we're going to get started on the quadratic formula today. Today is 5.6. 5.6 in your notes. And you see on my poster right away that we're going to learn a formula today. You should recognize this. should recognize that. What is this called, Sam?
Quadratic, simple form.
Very close. I'm going to set it equal to 0. He said simple form. You were very close. Standard form. Great. This is a standard form for a quadratic equation. It's not always going to be given to you in standard form. So today we're going to work on moving it around, getting it into the right format. If it is in standard form, you can use the quadratic formula to find your roots, to solve for your x, which is very cool because completing the square, which we attacked last week with a vengeance, is not always the funnest thing to do. This formula, I'm telling you, works every time if you're very careful with your positives and your negatives. I have found students in the past who would rather do this formula than factoring, which I prefer factoring. I've told you all this before. The factoring method for me is the easiest. But you can use the quadratic formula every time, and if you're comfortable and it works for you, and you're for sure going to get the right answer, why not go ahead and use it? This can be derived by taking your standard form and completing the square. We're not going to do that today, but we could have taken about 5 minutes and completed the square here with all letters, no numbers. And when we completed it, we would have come out with the quadratic formula. Now, don't laugh at me, but I'm going to sing the quadratic formula for you to the tune of Jingle Bells. Are you ready? Now, this is silly and it's corny, but I'm telling you, it works. Can I tell you where I learned that from? A huge football player that I taught many years ago taught me how to do this to the tune of Jingle Bells. So if it's cool for him, I think it could be cool for you guys. Negative b plus or minus radical b squared minus 4ac all over 2a. I know. You can laugh. It's corny. But it works. I'm going to sing it again. If you'd like to sing with me, feel free. Negative b plus or minus radical b squared minus 4ac all over 2a. Anyway, for whatever that's worth, if you want to use that little tune to help you learn it, feel free. In the meantime, I hope most of you wrote it in your notes, right? And you've got it nice and ready to go because we're going to practice it. Everyone write this quadratic equation down. I'm going to be nice and put it in standard form the first time. Okay? Remember, when it's in standard form, you can easily recognize A, B, and C. All you got to do is plug into the formula. How easy is that? Here we go. Juliana, what is A in this particular equation?
X squared.
Very close. The A is always the, and the B and the C are always the coefficient in the front. So, 1. Josh? Oakley? What is B? Negative 4. And Wyatt, what is C?
3.
3. You're ready to go. How easy is that? Are you ready to plug in? Here we go. Write my formula. Negative b plus or minus radical b squared minus 4ac all over 2a. Here's my formula. Let's plug in. So b is negative 4. Be careful. What's the formula say? Negative b. So the b always has to revert to the opposite side. Okay? So it's going to be a positive 4. Plus or minus b squared, negative 4 squared, 16. I'm going to plug in my a and my c.